In this video, we'll solve quadratic equations using three methods: completing the square, factorization, and the quadratic formula. We'll also look at common mistakes students make and learn how to choose the best method for each question. Stay tuned. Let's begin by solving it using the completing the square method.
This is a quadratic equation, and we'll solve it using the method of completing the square. But before we start, let's first confirm, is this really a quadratic equation? The standard form of a quadratic is ax squared plus bx plus c equals 0, where the highest power of the variable is 2. Now, let's compare it with our given equation. We can see it has an x squared term, an x term, and a constant. The highest power of the variable is indeed 2. Also, in a quadratic equation, the coefficient of x squared cannot be 0, and here it is 1. So yes, we can confirm that this is a quadratic equation. Next, we need to make sure the equation is written in its standard form, with the x squared term first, the x term in the middle, and the constant at the end. If it's not in that order, we simply rearrange the terms to match the standard form. In this case, the given equation is already written in the standard form. One last check before we start solving. Make sure the coefficient of x squared is 1. If it isn't, divide the entire equation by that coefficient to make it 1. In our case, it's already 1, so we're good to go and can move on to the solution. We'll solve this equation in 5 simple steps. Stay with me and you'll master the concept in no time. Step 1. Move the constant to the right-hand side of the equation. This is quick and straightforward. The minus 437 becomes plus 437 when it crosses over. Step 2. Now let's find the number needed to complete the square. We will write the equation with a space to add the number later. Take the coefficient of x, divide it by 2, and then square the result. That's the magic number we'll use to complete the square. Finally, add this square to both sides of the equation to keep it balanced. Now comes the most important step, so give this your full attention. We know the standard formula, a plus b squared equals a squared plus 2ab plus b squared. Let's use this to rewrite our equation. It will become x squared, and the term 4x can be expressed as 2 times x times 2 plus 2 squared. On the other side of the equation, the number becomes 437 plus 4, which equals 441. Now let's compare our equation with the standard formula. X squared plus 4x plus 2 squared can be neatly written as x plus 2 squared, and 441 can be written as 21 squared. The next steps are fairly simple. Let's move to step 4 and take the square root of both sides of the equation. Squares will be cancelled with the square root, and we will get x plus 2 equals plus or minus 21. Step 5, simplify and solve for x. If x plus 2 equals plus 21, then x equals plus 19. If x plus 2 equals negative 21, then x equals negative 23. Hence, the solution set of this quadratic equation is 19 and negative 23.
Now, let's move on to the next method, solving the quadratic equation using factoring.
This is a quadratic equation because the highest power of x is 2. Let's solve it using the factoring method. First, we multiply the coefficient of x squared and the constant term and write it down. Next, we copy the coefficient of x. Here comes the important step. Give your full attention. We need two numbers that give 10 when multiplied and give 7 when added. Let's try. 1 times 10, which gives 11 when added. 2 times 5, which gives 7 when added. What do you think? Which pair should we use? ... You got it. It is 2 multiplied by 5 because it gives 10 when multiplied and gives 7 when added. can we write 7x as 5x plus 2x? Of course, yes. Now let's replace 7x with 5x plus 2x, which is quite straightforward, as we are not changing the overall value of 7x. Now, we group the first two terms and the last two terms and take out the common factors. From the first group, we take x common, leaving x plus 5. From the second group, we take 2 common, leaving x plus 5. Now, since x plus 5 is common in both groups, we take it out again. The remaining factor is x plus 2. We're very close to the solution now. Two terms, x plus 5 and x plus 2, are multiplying to give 0, which means either the first term is 0 or the second term is 0. So, if x plus 5 equals 0, then x equals negative 5. If x plus 2 equals 0, then x equals negative 2. Hence, the solutions of this equation are x equals negative 5 and x equals negative 2.
And finally, let's move to the third method, solving the quadratic equation using the quadratic formula.
This is a quadratic equation, and we'll solve it using the quadratic formula. But before we start, let's first confirm, is this really a quadratic equation? The standard form of a quadratic is ax squared plus bx plus c equals 0, where the highest power of the variable is 2. Now let's compare it with our given equation. We can see it has an x squared term, an x term, and a constant. The highest power of the variable is indeed 2. Also, in a quadratic equation, the coefficient of x squared cannot be 0, and here it is 6. So yes, we can confirm that this is a quadratic equation. Next, we will make sure that the equation is written in its standard form, with x squared on the left, x term in the middle, and constant at the end. If not, move the terms around to write it in the standard form. In the given equation, it is already 1, so we will now move to the solution. We'll solve this equation step by step. Stay with me, and you'll master the concept in no time. Let's write the quadratic equation again. Here, the coefficient of x squared is a, the coefficient of x is b, and the constant term is c. We'll use the quadratic formula to solve it, which is written like this. Once we know the values of a, b, and c, we can simply plug them into the formula to calculate the values of x. Now comes the most important step, so give this your full attention. To find the values of a, b, and c, we'll compare the given equation with the standard quadratic equation. Here, the coefficient of x squared is 6, so a equals 6. The coefficient of x is 1, so b equals 1. And finally, the constant term is negative 15, so c equals negative 15. One important thing to remember, and make sure you don't make this mistake, it is to carefully note the signs of the coefficients and the constant term. In the given equation, the coefficient of x squared is positive, the coefficient of x is positive, and the constant term is negative. Always note these signs correctly when assigning the values of a, b, and c. Now we'll substitute the values of a, b, and c into the quadratic formula. The value of b is 1, so let's place it here. Again, we'll use b equals 1, which becomes 1 squared. Next, we keep the negative 4 outside and substitute a equals 6 and c equals negative 15. Finally, in the denominator, we'll put the value of a, which is 6. And next steps are pretty straightforward. It's all about simplification. 1 squared is just 1. Then 4 times 6 times 15 gives us 360. Pay close attention to the signs here. Since we're multiplying two negatives, negative 4 and negative 15, the result becomes positive. Finally, 2 multiplied by 6 gives us 12, which we'll place in the denominator. Let's simplify it further. 1 plus 360 is equal to 361. We can also write 361 as a square of 19. Now, the square of 19 and the square root will cancel, and the answer will be like this. There are two solutions for x, one with the positive value of 19 and the other with the negative value of 19. Let's solve the first solution. It's pretty straightforward. Both the numerator and denominator are divisible by 6, so the fraction simplifies to 3/2. For the second solution, both the numerator and denominator are divisible by 4. After dividing, the numerator becomes -5 and the denominator becomes 3. So the solution set for the quadratic equation is 3/2 and -5/3.
Want to guarantee 100% on your quadratic equations? Then you need to avoid these common blunders. In this video, I'm breaking down the errors teachers see all the time, so you can stop losing easy marks.
Common mistakes students make while solving quadratic equations. Mistake number 1. Many students don't even check if the given equation is actually quadratic, and they jump straight into solving it with quadratic methods. Let's take a moment to see how we can check if an equation is truly quadratic or not.
The standard form of a quadratic is ax squared plus bx plus c equals 0, where the highest power of the variable is 2. Now let's compare it with our given equation. We can see it has an x squared term, an x term, and a constant. The highest power of the variable is indeed 2. Also, in a quadratic equation, the coefficient of x squared cannot be 0, and here it is 1. So yes, we can confirm that this is a quadratic equation.
Mistake number 2. Not writing the equation in its standard form. Let's take a moment to understand what that really means.
We need to make sure the equation is written in its standard form, with the x squared term first, the x term in the middle, and the constant at the end. If it's not in that order, we simply rearrange the terms to match the standard form.
Keep in mind that a is the coefficient of x squared, b is the coefficient of x, and c is the constant term without any variable. If the equation isn't written in standard form, you might end up picking the wrong values for a, b, and c. And if you choose wrong values of a, b, and c, then the entire solution will be wrong. Mistake number 3. This applies when you're using the completing the square method. Always make sure the coefficient of x squared is 1. If it isn't, divide every term of the equation by the coefficient of x squared before moving forward. Mistake number 4. Sign errors. Many students forget to pay attention to negative signs, especially when applying the quadratic formula. A small sign mistake can completely change the solution. To understand this, let us compare the standard quadratic equation with the given equation. The value of a is the coefficient of x squared. In this equation, the coefficient is 1, so we can say that a equals +1. Next, the value of b is the coefficient of x, hence b is equal to +4. And finally, c is the constant term. Here, c equals -10. Pay close attention to the minus sign. If you drop it, your solution will be wrong. To recap, if a coefficient isn't written, it means the value is 1. And always watch the signs of the coefficients. Missing them can change the entire solution.
Now let's answer a very practical question. How do you decide which method is best to solve a quadratic equation? When faced with a quadratic equation, you typically have 3 powerful tools to use. Number 1, the factoring method. Number 2, completing the square. And number 3, the quadratic formula. But which one should you use? Let's break them down one by one to create your perfect problem-solving strategy. Step 1, Check if the equation can be factorized easily. If the numbers are small and you can quickly find two factors that add up to b and multiply to a multiply by c, then factorization is the fastest and cleanest method. Step 2. If factorization is not obvious, try completing the square. This method is very useful for understanding the concept of quadratics, and it works especially well when the coefficient of x squared is 1 or can be made 1 easily. Step 3. Use the quadratic formula when nothing else works. The formula is universal. It always works, no matter how complicated the coefficients are. It's the safest choice when factorization looks messy or impossible.
And that's all for now. Thanks for watching.